welcome to Eurodreaming, and thank you for hanging in there. This is, I know, the last formal session of the day. My name's Dan Appleman. I am a developer. I'll say a few words about that in a moment. I am the author of the book Advanced Apex Programming, a Salesforce MVP. I do courses on Pluralsight, and I'm the CTO at Full Circle Insights, which is a Salesforce ISV partner that does marketing analytics. Now, in the world of Salesforce, we use developer many different ways. So for the purposes of this session, and this session only, when I say developer, I refer to someone who writes code, especially Apex code. And when I refer to admin, I'm referring to someone who does declarative, workflows, processes, creating fields, things like that. So again, not a universal definition, but that's the definition we're going to use for this session. Now, I just distinguish between the two. But the reality is that developers and admins, we're alike. We do the same thing. What we do is we solve problems and implement processes in Salesforce by modifying and customizing metadata. So this is the first thing that is important that every admin be aware of, is that Apex code is metadata. In fact, this is what an org looks like from a developer perspective. We have a bunch of metadata, and here we have some triggers. Oops. Right there. We have some triggers, and we have some Apex classes, and look here, we have workflows. And if you actually look at a package, which is a file that defines metadata in an org, you can see that workflows are just the same thing as an Apex class and an Apex trigger. So we're all doing the same thing. We're modifying metadata. And we all live in the same metadata, which means that they have the ability to interact with each other. Workflows, processes, declarative constructs can absolutely interact with Apex code, and vice versa. That includes the ability to break each other, which, I hear some chuckles, we know that that happens. Frequently do. Well, we're going to talk a lot more about that. So the question then is, well, let me start with this question. Have any of you experienced any of these? So, by a show of hands, has someone changed something and broke something else in an org? Okay. How many of you have orgs that you have fields that exist and you don't know what they're doing there? Okay. Workflows or processes that you don't understand? Okay. Have you ever tried to deploy a change set, but unit tests are failing and you don't know why or when they started failing? Okay. Code in an org, Apex code or triggers, you don't know what it does. Have you ever tried to figure out something you did a year ago and you just don't know where that came from? Okay. And have you ever tried to figure out who changed something and you just don't know who did it and when they did it and why? This is our world. And this is not just an admin world, this is the world of software development. Because every single one of these things applies to software developers as well. Somebody changes something in one piece of code and it breaks the application. Fields, variables, things exist, you don't know why. Software processes, functions, code that you don't understand. When you try to when you try to build your product or deploy it to a live website or something like that and it fails, you don't know why. All of these things, this is the world of software development as well. So then, if we're the same, admins and development, we're doing the same thing, and we're suffering from the same problems, then what is there that you can learn from software development? Well, let's think for a moment about the world of admins. Going the wrong way. So the world of admins is 20 years old. I don't know if anyone recognizes that. I don't recognize that screenshot. But the early years don't really matter because there just wasn't that much complexity back then. There hasn't been really a lot of formal research in admins. I mean, I don't think I've ever heard of anyone getting a PhD in workflows, for example. I don't think that exists. And as far as how many people are doing this, well, Salesforce at Trailhead Day said 6 million developers. I don't know how they count. They've never said how they count. I think that anytime you go to success.salesforce and it says, welcome to success community, that counts. And since that happens every time you're logged in somewhere, I myself am 50 of those, I assure you. So anyway, that's our world as admins and in Salesforce. But the world of software developers, well, 73 years since ENIAC, one of the first programmable machines, and Wikipedia says there are about 25 million software developers in the world. And there's been a ton of formal research. You have people who have been studying it and doing all kinds of research in terms of how to develop software. So there is this big difference between the two worlds. And all of these problems that we share, we know how to solve them. That doesn't mean we always do it. But we know how to do this. We know how to eliminate these problems. And that is what we're about today. Now, this is not about learning to code. And I just want to say a few moments about admins learning to code. If you're an admin and you want to learn to code, God bless you to learn to code. The reason to learn to code, in my mind, is because you love coding. And I love coding. I still write code all the time. But don't do it because you think you're supposed to and you have to. An analogy that I use for this is, imagine a hospital, and you have a hospital administrator who's brilliant and makes sure that everything is done on time and people have the supplies they need and everything functions and rooms are allocated and so on. And someone goes to them and says, well, you work in a hospital, why aren't you a surgeon? So the person goes and learns surgery and they end up becoming a lousy surgeon and the hospital falls apart because they have no administration. Admin skills, business analysis skills, solution skills, declarative skills, that's a big world, and it keeps getting bigger. They just bought Tableau, for God's sake. Software development is its own huge field. It's hard, right? It's a lifetime discipline. Do it if you love it. Don't do it because you think you're supposed to. However, it's good for an admin to know how to read code. Reading code is infinitely easier than writing it. And I'm going to show you a few examples of that. But what this session really is about is taking the lessons of the software development world and applying them to the declarative world. So let's get started, and going the wrong way, with number one. Now, in sessions like this, it's common for people to start with like the least important and build up to a gigantic climax of like the most important issue. We're not going to do that here today. We're going to start with the most important thing. If you take nothing else from this talk, it's going to be this number one, the idea of application lifecycle cost, which is what it takes, what does it cost us through the life of an application from the beginning concept to finally nobody's using it and we've given up on it. This is what an application lifecycle looks like. And it's just as true for declarative as it is for software developers. You have to define the requirements. What are we supposed to do? What are we trying to do? What are we trying to accomplish? Then we have to design our solution. How are we going to do it? Are we going to use process or flow or workflow or so on? Then we actually need to build it. Then we need to test it. Then please document it. And then we have to maintain it over time. Now, sometimes, if you have a developer background, you might say, ooh, that's waterfall. We're agile. Agile is a methodology, and it's a wonderful methodology. But all agile means, when done correctly, is that you get to loop through these a few times and iterate. All the steps are there, but you go through a different pattern and order of them. Sometimes agile people means we get to leave it out. Like, let's not figure out what the requirements are and just build stuff. And if we do it often enough, sooner or later we'll come up with something people like. Don't do that. That's not the correct agile. And that ends up, if you leave out any of these steps, the odds of your project failing increase dramatically. And let us be clear, studies show consistently that software projects fail at least 50% of the time. Probably more. Again, that's why we have these PhDs doing this research. They're telling us that. So you have to have all these steps, but, and here's where things get really serious and really important. That's not what they cost. That's just what the steps are. This is what it really looks like. Every study I've ever heard or seen of that evaluates the cost of building an application shows that at least 50 and as much as 80% of your total costs are in the maintenance, not in all those other steps. Now this is profound, and this is something that younger developers do not know. In fact, this is perhaps the biggest difference between a junior developer and a CTO is that the junior developer has no idea, and the CTO lives this every minute. It's something that's taught poorly, but it is all important. So let's think about what this means from a Salesforce perspective. First of all, is it true for Salesforce? Yeah. Now, I cannot prove it to you because nobody's done a PhD yet or done a formal research study to actually evaluate these, at least not that I know of. But I think it's true. And as evidence, you all have jobs. I mean, think about a Salesforce deployment in a new company that an implementation partner came in and said, okay, we're going to implement it. There, it's ready, we're done, you're on your own. Right? Right?
I know those.
Yeah, and they fail. They fail every time, right? You have admins because you have to maintain it, you have to educate, you have to adapt, you have to keep changing things, you have to adapt to Salesforce releases and critical updates and all this kind of stuff. It's all maintenance. The migration to Lightning was one huge maintenance task, right? Because everything worked, right? It worked, your customers were happy, your salespeople were happy, everything was fine. All that effort to switch to Lightning was maintenance, it was maintaining the org. So I think it's even higher on SFDC than it is in traditional software development. Another curious thing from a software developer point of view is developers, is there a way to get rid of this whistle? Audio people, is there a way to adjust that? I keep hearing feedback. Thank you. It's a little annoying. Anyway, as a software developer, I frequently see developers obsessing over what is the newest language or the newest technology that I can save a few keystrokes or a few lines of code. And that just drives me crazy because even if you could eliminate all of your time coding, you're going to eliminate maybe 10% of your total cost. Because that's about what the implementation time cost is, 10%, when you look at the application lifecycle. So that's an aside. Here's another thing. Anytime your company thinks of bringing in consultants to build stuff and they will go away, they don't go away. And it always takes longer than you think. Always. And I know this speaking as someone who's done consulting. And anytime someone says, yeah, it's going to be a 2-month project, I just book it 6 months, right? Because it always takes longer than you think, because you're always going to end up with maintenance. So when you're thinking about bringing in a consulting firm to work on stuff, which there are many great reasons to do that, always think about, evaluate them not just on what it's going to cost to do the initial build and the initial project, but think of them, do I want to be married to them for a while? Because, and budget accordingly. Budget with the assumption that, you know, I'm going to be spending another 50% on the maintenance side. Finally, anything you do, any investment you make that reduces maintenance costs is going to give you good ROI. It's going to give you a good return. You will have a very hard time explaining that to management, but it's true nonetheless. And the failure to understand that is a management failure. Let it not be yours. Number 2, unit tests are not about testing, right? Now, let's back up for a moment, just in case. What is a unit test? A unit test is a piece of Apex code whose sole purpose is to test other code. It sets up data, it changes some values, it looks at the results, and at the end, the org is returned to its initial state. So Apex unit tests are very easy and very safe to do, and that's what they do. Their job is to test other Apex. They are costly. When I'm building out a project, it probably costs me as much time and effort, if not more, to build the unit tests than the code itself. So if unit tests were about testing the code, the initial test, they would be a complete waste of time. But in fact, they're not. They're about detecting when things break. So let me give you an example here, and I recorded this because I did not want to spend a lot of time watching the unit test. Here's how to run a unit test. You go up to the little gear, and you bring up the developer console. And you're going to see the test tab down below. And you say test new run, the name of the class. You can pick as many classes as you want, as many tests as you want. Click on run. And after a few minutes, but in the demo a few seconds, you'll get a little green check mark that says, hey, you know, it passed. And over here, you'll get a look at your code coverage. 100% code coverage. Woo! Yeah, exciting. We're going to come back to that. So it's not about the initial test. You're going to do manual testing anyway. It's all about detecting when someone breaks something. It is about maintenance. Now, in the software development world, we call this breaking the build, right? You don't want to break the build. You don't want to make a change that's going to break the build. And it's so serious that there are memes that have been created about this. Do not break the build. It is probably the most embarrassing thing that can happen to a software developer is that they've committed a change and it broke the unit test because it means they just blew it completely. So this applies to declarative as well. You don't want to do something declarative that breaks all your unit tests. We're going to get back to that as well. But first, let's talk about that code coverage. Woo, 100%, yay! Code coverage doesn't matter. Code coverage is fine. All this obsession, 100% code coverage. If you see 100% code coverage, if you have a developer like, I have 100% code coverage, they've just wasted your money. Because it means that they spend time creating code to test trivialities like property settings or exception handlers or stuff like that. So why does SFDC obsess over code coverage and require it? Because it's the only thing they can measure. They can't measure whether your code works or does something specific. They can just measure whether lines of code execute. So they're hoping that if you get at least 75% code coverage, it means you actually tested something. But that isn't always necessarily the case. So here's the code of the test we just ran. And again, a little bit of reading code. You know it's a test because it has is test at the beginning. It could also have the word test method in here. Right? This is something anybody can go look at. They can look at test classes and say, oh, this is a test class and so on. And you know, we get some leads that were created earlier in the test. I'm not going to talk about that. This particular example, when the lead status changes to working contacted, we create a task. Because that's sort of a cool thing to do. Say, yeah, I know you can do it in a process, but we're doing it in Apex code. Someone changed the lead status, we want to create a task. So here we set the lead status to working contacted in our test, we update the leads, and test is done. 100% code coverage, but what we didn't do is check whether those tasks were created. This is not a test. This is like, the example I use is if you ever have a treadmill test at a cardiologist for heart detection, right? And you know, you run really hard and they have you wired up. Imagine they didn't wire you up. They just made you run really hard, and if you don't drop dead, they figure you're okay, right? So this looks like a unit test and it gives you 100% code coverage, but it's not testing anything. So let's go ahead and put in the test, where we're actually going to select, look for the task where the who IDs or the leads that are associated with those, the tasks that are associated with those leads, and make sure there are at least 10 of them, because I'm not showing it to you here, but I created 10 leads. So we're going to go ahead and we're going to run that, and we know how to do that now. We go ahead and new run test, pick our test class, and run it, and several minutes pass, and we get a failure. And you can even drill down into the failure and see that exactly where it failed, which turns out is it didn't create any tasks. But we have 100% code coverage, folks! All right, now we have a unit test. So it turns out what the problem was is that when I was creating the task, I said what ID. I said the task's what is the lead instead of the who is the lead. So it failed, and when it failed on the insert of my test, or the insert of the code, it caught an exception, which is why I have 100% code coverage, because I have code coverage for my exception. I'm measuring my failure. So if I go ahead and fix this, then let's go ahead. Okay, it's going to run again. Assume that we fix that code, run it. Same thing. I don't mind showing this because it's good for everybody to know how to do it. And this time it's going to pass. And oh my lord, it passes, but our code coverage is only 94%. Oh. Now, could a developer create another test to validate the error condition? Sure you could. It's a complete waste of time and money because that's trivial code. So I'm very happy with that. Our code ships at about 80%. It's fine, because the cost to get that extra 20% for trivial cases, for strange cases, for cases that are specific to certain kinds of orgs, it's just not worth it. Okay, next thing we learned from development, which is related, is test before you deploy. Okay, now, what does this mean? Please don't build on production. Please. Please. Okay? Build on a Scratch org. More on that in a moment. That's Salesforce DX or a dev org or a user acceptance testing org or a sandbox. Build anywhere else and run the unit tests. Because those unit tests, assuming they're real tests, they're your canary in the coal mine. They are the warning. They are the easiest and quickest way for you, after you make a declarative change, to discover if you broke something that was implemented in code. It can save you tons and tons of trouble, right? It will prevent you from 3 months going by and you try to deploy something and, oh, unit tests are failing. Who did it? Why? When? Right? So only after you've done these steps, then deploy. Now, what is this example? Oh, so here's an example where what we do is we're going to we create a declarative construct, and this is going to, when it sees the lead status is working contacted, it's going to change it to working harder, which is going to break our unit test, right? So our field update is changing the new field value, the status, to working harder. Our unit test, it turns out, is asynchronous, which means it's going to try setting the lead status to working contacted, but then this workflow is going to change it to working harder, so the tasks won't get created, and this way, and the test, I'm not going to walk through it, will in fact fail. So that's an example which you've seen in your own lives, in your own work, where something declarative can break a unit test. Now, I ask you to run unit tests before you deploy. Just as in the software development world, I would ask developers to run unit tests before they commit or deploy. This requires discipline. We have no discipline, right? This is the real world, folks. You can tell the developers all day, be sure to run unit tests before they commit. No, I just committed it. It's like, did you run unit tests? Okay. They're not going to do it. In the real world, you're on a tight schedule. It's like, no, I don't have time. Our unit tests take 2 hours to run. I don't have time. I need to get it in there. So real world now, I can ask you all day to go through this process. It's not always going to happen. So in the software world, we have something called continuous integration, which means we automate and enforce. We don't trust people to have the discipline. We build a process that automates it and enforces it. Now, here's the interesting news and the exciting news. Up until very recently, we'd get stuck here. Because I'd say, well, you know, we software developers get to do this, but you can't. But that's not true anymore. Because Salesforce came out with something called Salesforce DX. And Salesforce DX provides the infrastructure to automate a lot of different things. So I'm going to give you a teaser now of some of the techniques that you're not going to probably use today, but they're going to become routine probably within a few years as the tooling gets better, as best practices become more familiar, and so on. And then I'm going to talk a little bit about what you can do today. So imagine that we have this error. We know that we created this workflow that caused the failure. So we're going to edit it now. We're going to change it. And we're doing this in what's called an SFDX scratch org, which is a temporary org that you build in order to do customizations, whether code or declarative or so on. And you can test them out on this org that will go away after a while. It's a temporary work org. It's called a scratch org. So we edit it, we save it, and we're going to run the unit test to make sure that we fixed it. Right? Because our scratch org has the unit test as well. And sure enough, everything's good. Now, what do we have to do? Well, we have to get this somehow. We want to run the unit tests on the target org, right? We want to make sure that all the unit tests pass, and we want to do the deployment. And you think, okay, now I have to go, and I have to do a change set, and then I have to go and I have to run unit tests and so on. But we're now in the world of Salesforce DX. So we can create a script. And what you have up there is a very simple script that says, okay, SFDX, Salesforce DX, pull any changes I made, convert them to metadata, standard metadata format, deploy them to a target org, running all the local tests that are not those that belong to AppleStage managed packages, because you never want to waste time running those. Another story, but those will fail and it doesn't matter. So you run the script, and all you have to do is type in the name of that script, and it's going to go to work for you. And it's going to happen really quickly here, but this can be a process of 20, 30 minutes, an hour. Doesn't matter. You walk away, because it's going to pull in the changes. It's going to do convert to metadata. It's going to go ahead and do deployment. Right? This is just a little bit of a taste. In the software world, we call this a software development pipeline. And they can get really sophisticated to the extent that somebody can, a developer can commit a change and say, okay, here's my change. And it will go off and it will spin up temporary QA orgs. And it will deploy it to the QA orgs. And it will run the unit test there. And then it will go and commit it into source control. More about that in a minute. And it will go through an approval process where it requires approval from someone. And they will look over what you did, and they will click OK, and then it will go ahead and maybe run unit test again and automatically deploy to production. And the developer doesn't have to do a thing, right? The process automates the efforts, and it enforces the discipline. So really cool stuff, and the technology now exists to do that. So let's go ahead and see what happens if I'm going to change this code. Back here, you get rid of that 30-day delay. Right? So because what the formula did is it said, I only want to change this when it's 30 days old. Now we're going to change it back to code that's going to fail, a workflow that's going to fail. And we're going to run that same script again. There we go. And again, it's going to pull down metadata, a workflow that's going to break the build. It's going to convert it again to metadata format. And now it's going to go ahead and once again try to deploy, running all the local tests. And this time, that was the one that passed. I did that one again, going the wrong direction. This is the one that fails. I have the up button and the down button, and they're sort of hitting the wrong ones sometimes. I apologize for that. This time, metadata deploy operation fails. And what this means is if you are using a script like this, if you have the discipline to use a script like this, you're never going to break production. It's just not going to happen. You say, okay, this is nice, Dan, this is coming in a few years, the technology is not mature yet. What do I do today? This is a tool that I published, that's my book. That tool is called the Apex Test Tracker. It's used in hundreds of orgs now. I don't know how many because I don't care because it's free. What it does is very simple. It sits in your org, and every 24 hours it runs all your unit tests. And if it sees a test fail that used to pass, it sends you an email. That's it. It is your heads up that simply says, hey, sometime in the past 24 hours,
Can you go back to this one?
advancedapex.com/test tracker. And what it basically gives you as an admin is a warning that says sometime within the past 24 hours, someone did something that broke a unit test. And then you can raise alarms, you can look through the setup audit trail and see what happened, and you can be proactive. And you will never again run into a situation where you're on a deadline, you're trying to deploy a change set, and existing unit tests are failing, and you don't know how and why and when that happened. So it's a really simple, lightweight, it's a managed package, it's gone through security review, and it's free. So what more can one ask for? You can test more than just code. You know what? You can write unit tests or workflows. So let's take a look at what that might look like. And again, you shouldn't do this. This is something if you have a developer, have them do it. But this workflow, here's code that makes a bunch of sample leads, and it sets the created date to either, to whatever you want it to be set to. And we have one unit test that sets the created date to more than 30 days old, so it's expecting the status to change to working harder. And here's another one that sets the date to 29 days old and expects the status to still be working contacted. So it's going to validate that workflow. Now there are problems with this. It's expensive. Anytime you change the workflow, you're going to have to change the unit test. So why would you invest so much money to create a unit test for something declarative? Well, the reason again is you're not there to test something declarative, you're there to test over time that it doesn't break. It's all about regression testing. So especially for a complex process or flow, it just might be worth the investment as compared to having something break and then having data get corrupted for months and you're not even aware of it. Okay. We're doing okay. Source control. This is something that we have as software developers that used to be really hard for admins. So here's an example of how do you check what's happening in metadata right now. You have to set up audit trail, you can look at modified dates. Processes, you have versions of processes, so that's sort of cool. Here is a source control application, a source control, this is a program called SourceTree, which is a user interface over a source control system called Git. And this is actually the examples that I went through for this session. And what you can see is basically every step of the way, you can see what changed, who changed it, and exactly what changed in the code or the metadata. And remember, workflow, process, flow, declarative, it's metadata. Code is metadata. And Git doesn't care if it's code, right? It's metadata. That is a Git repo entry for a change in a workflow. Now, yeah, it's a pain to read, but it's a lot more painful to not know who changed it and when. At least this way you can go back and see, oh, here's what it was before, here's what it is now. That's pretty cool. So incorporating source control can be a huge benefit when it comes to maintaining your org. So in the ideal world, you build, you make your changes, you pull them from your scratch org, you deploy, and you commit somewhere along the same time. And you have that detailed history. But you don't have to have a full process to use source control. Remember, you can always pull in metadata. You could, for example, have a set of metadata that you're monitoring all your declarative stuff, and every day just pull in the metadata, throw them into your repository and see has anything changed. And basically commit that. You can even commit pieces. Two workflows changed. Okay, I'm going to do one commit for this workflow and give it a description, and another commit for this workflow and give it a description. So you can track the history over time and know everything that's going on. Here's another thing, wrong way again. To learn Git, there's a trail, Git and GitHub Basics. I put it up here because it's a trail, you gotta say trailhead. I'm not a big fan because Git and GitHub are two very different things. And Git is the one that's important. Pluralsight, getting started with Git. I like that session. That's a good way to learn Git. Use source tree so you have a user interface. Don't try to do everything in the command line. In the software development world, we do project management. And the tool we use, by and large, is Jira. Jira is awesome. It basically means that anytime you make a change, a workflow process, whatever you're changing, a new field, you create an issue in Jira that says, here's what I'm doing. It's a change. And it can be tied to source control. So here, for example, this is actually out of our own product, our own Jira instance. And this is what I live every day. Our whole team lives every day in this environment. What are some key points? There, that goes to Confluence, which is a wiki, which is the requirements. That's where the requirements or the design spec is. Okay? Down below, which is cut off, are any comments during the development, the history, questions that came up. They'll all be in the comments here. And here is the link to the changes in source control, which means that at any time in the future, I can say, oh, here's this feature. Okay, here were any developer comments that happened during the development, and here's the code that was created, and all the commits and so on. But it's better than that, because it goes both ways, which means that 2 years from now, some new person can come in, and somebody says, well, you got to change this workflow, and they'll look at the workflow, and they can see who created it, or who changed it last. And they can go and find exactly what commit that change was, and click the link, and go directly to here, where they can see the spec and the comments, and warnings. They can go back to the manager and say, well, I really shouldn't change that because 2 years ago you asked for this. And if I change that here, you're going to lose it. And the manager will say, oh, I didn't realize that. Let's rethink it. Think about the time and cost that comes from that. A couple of quick ones because we're running out of time. Oh, to learn it, Jira getting started. I like that course. But there are tons and tons of resources on Jira. Quick thing, comments. You can put comments in formulas. Do it, please. They do not count against your compiled limit. They are very, very helpful. They're quick, easy. Please take the time to do it. If you're software developers, I say comment your code. Comment your formulas. Formulas are code. A lot of people learn formulas. We use formulas everywhere, but a lot of people pick up formulas just sort of through samples and happenstance and so on, but they're code. And I believe it should be taught like code. So if you've ever struggled with things like dates and time zones, right? Every software developer I know wishes that Galileo had been wrong and the Earth would be flat, because we hate time zones. Time zones are a nightmare to deal with. But how many of you have ever dealt with the logic of and, or, not, and trying to get it right? That's because you're not taught Boolean algebra in school. But it's important to know. So I actually created a course, Formula Fundamentals in Salesforce, which teaches formulas the way I would teach a beginning programmer the code that's in formulas. So if you're looking for a resource, even if you're experienced at it, take a moment and check it out. The problems we started with are nightmares. Someone changed something and broke something else. Unit test will deal with that. Fields exist, you don't know why. Git will deal with that. Workflows in a process you don't understand. Comments get in Jira. Trying to deploy unit tests or code you don't know why or when they started failing. Salesforce DX, continuous integration. Code on the org that exists, you don't know what it does. Get in Jira. Trying to figure out something you did a year ago and why. Get in Jira. Can't figure out who's... We know how to do this. We can get rid of these problems and save tons and tons of time and money. The technology exists. What doesn't exist is the culture and the discipline. And that's the hard part, right? That's the hard part. That's an investment. For that, wrong way again. It's a play-by-play on the Pluralsight by Patrick Watkins and Don Watson on implementing sustainable and scalable Salesforce governance. which talks about building that culture, building that discipline for governance, for discipline in an org to address the fact that maintenance is where our costs really are, and to eliminate and minimize those costs as much as possible. And with that, thank you so much. Do I have any time for questions? Two questions. Do I have any questions? Yes, sir.
So the whole thing with getting your code in Git and also your flows, your declarative stuff.
Yeah.
Right now, to get that working, you do have to do a little bit of coding and stuff like that. Do you expect that Salesforce is coming up with more also declarative way of managing that?
Right. Do I believe that there will be a declarative way of managing all of this stuff that right now requires coding and so on? And the answer is yes. I don't know if Salesforce is going to do it, but this is a golden opportunity for third parties and app exchange packages and standalone software. So I believe it will happen because now the technical infrastructure supports it. So I have high hopes, yes.
Do you believe that admins should routinely be writing tests for Flow and Process Builder as part of, or even asking their developers to write tests for Flow and Process Builder as part of daily routines?
I believe that admins should have a way of testing their workflows and processes. I do not necessarily believe they should be writing Apex unit tests because those are very costly. But it could be an Excel spreadsheet, step by step, something like that, that they do reality checks.
They should still do tests.
You have to do testing. You have
yeah,
to do
proper
testing.
test plans, but not necessarily.
It doesn't necessarily have to be Apex code, Apex unit tests. But regression testing it's very painful. And this is where I talk about the cost of maintenance is half the cost. You're either going to pay for it in doing the testing, or you're going to pay for it dealing with the mess that happens when things break. One way or the other, you're going to pay for it. It's just less painful to be proactive and do the testing. Anyone else? One more. Yes.
Because this is declarative. Why it's not fair? Is it because of the validation?
Oh, you can break declarative for all kinds of ways. For example, if you have a process that creates records and you create a required field, right? That can break it. Or if you have a process that is looking for a certain condition and somebody creates an Apex code that changes the condition or changes the way the org works, so that condition never applies anymore. All kinds of ways we can break each other. Thank you very much.